All right, number 45. We have 1/3 ln e to the 18 equals log base 10 to the 6. It says the side of each statement is true, false, justify the answers. Using the properties of logarithms, show how the two sides are the same or how they're different. Okay, so we did like a really nasty, mean thing. We mixed natural log and e all with the same thing. So we have to kind of remember, these cancel out, so I get 1/2. The 18 drops down. So that's going to give me 9 on the left side. Is that okay so far? Remember when we have a log here, that cancels out, so I get 6. Yeah. What's 1/3? That's going to make a difference for our answer. So that means that's going to be a 6. Hey, 6 is equal to 6 last time I checked, unless y'all know something I don't know this week. So I'd say this works. This justifies. What else did you see on the homework? Yeah. 3, 4. We didn't have to do 34, but I'm happy to do it. I give you evens or odds? I don't even remember. Silence. It's like, I don't know. He gave us all of them. He's an idiot. Doesn't remember. Oh, that happens too. Let's minus it right there. Okay, so we want to condense it, correct? Put it back together under one log sign. So eventually I'm going to get an answer of log base 7, but we got to figure out how it's going to work. Is my problem written right? 1/3. Okay. All right, so I have to realize this exponent needs to come upstairs. I can put these together, and that's going to give me log base 7 of xy, and xy is now going to be raised to the 1/2 power. Is that okay so far? And then this 3 is going to move up here, so I get minus log base 7 of z to the 3rd. Good so far? Now, I'm going to leave it up to you. You can distribute that 1/2 both to the x and y, so you have x to the 1/2, y to the 1/2, or you can leave it grouped to the 1/2. It doesn't matter. There's not more right or wrong, okay? So I'm just going to leave it together. So I know I have xy as a numerator, as the 1/2, and then that z to the 3rd is going to be a denominator. So the only thing different, what I had said before, is if you wanted to, you could have had it this way. Come on. Y to the 1/2 over z to the 3rd. So this answer is totally fine, or this answer is totally fine. It becomes your choice how you would like to represent it. What else would you like to see? We seem content, happy. Everyone's proud of the work. Okay. Let's get that packet of notes out. If you need another packet because you misplaced it or you left it on your desk at home or on the counter at home, got the packets up here. And let's go back in time. 9i. Hi. Okay, so I think what we're going to do, so I have in here, I have I, and then I have J, which will be Monday, and then I'll have to get you K for Friday. Oh, this is rough. This is a hard dilemma that I'm having. This week of testing really messed things up. So if I didn't have the week of testing, I would have given you the quiz on Wednesday next week. It's not going to happen. Being that Friday next week will be a review, that means, I'm sorry, don't hate me. That means that Monday, a week from Monday, will be the quiz. Sorry. Can you handle it? Just this one time. I'll try not to make quizzes on Monday after that, but is it okay? Anyone hate me? Like any hate mail coming already? You already sent me that email. Mom, please send Stirrup an email, and he's a big jerk. We're good? Okay. All right. Evaluating logarithmic functions. Now we have to remember the expand, condense rules that we're going to be using. And these are all going to start applying when we start working these problems. When you evaluate a lot of these, a lot of times you want to make sure that you have these logs down. So log a times b is the same thing as log a plus log b. Log m over m is the same thing as log m. Subtract log n. Because there's a subtraction before the log n, that means that n would be a denominator at some point. And then if I have log c raised to the d, the exponent can come down front, which gives me d log c. Okay? So those are important rules. Expand and condense go back and forth. So these rules can go each way. Okay? Now, sometimes it makes it easier to condense something. Sometimes it makes it easier to expand something. Sometimes you don't have to do anything to it. Okay? But we kind of have to keep these in our wheelhouse of things that we could do with logarithmic equations. All right, so all we want to do now is we just want to condense it. So number one, the 3 out in front of the log x, that 3 means that x is going to be raised to the third power. Agree? And then being its addition, that means we're going to go ahead and multiply. So I'm going to go log 6 x to the third. Now you're going to notice that I put the number first and then the letter second. Now someone's going to ask, what if I had log x to the third times 6? That's technically still correct. It's just kind of dirty math at that point because you want the number and then the variable to come. Does that make sense? Second problem, I have a 2 in front of log c. That means that c is going to be raised to the second power. I have a subtraction sign in front of 2 log c. So that means that c to the second will be a denominator. So this is going to give me log b over c squared. I'm totally fine with that answer. I think at some point they're going to want you to group it. I'm not too worried about that, but just be aware that future classes might have you group it. And that just means you're putting in parentheses. That means that you know that that allows you not to have an answer of log b, and then you have a big old division sign over c squared, which is incorrect. That's the reason you would want to group it. Okay? But if I could totally tell that you're doing log of a fraction, perfect. Make sense? All right. X is going to be raised to the fourth. 6 is not going to be raised to anything. Those are both numerators. Y to the third will be a denominator. Why? Why is that? Subtraction prior to it. Good. So I'm going to get log 6 x to the fourth over y to the third. And again, it becomes your choice if you'd like to keep that grouped. Grouping shows that you kind of have the understanding that the entire fraction we're doing the log of. I need to find a place for this where I'm not going to go fall on it. I bet you if I put it like right here. Have your cameras ready though, because you know I'm going to take a trip. And send it to Mr. Silva saying, look what Mr. Stirrup did. This was funny. Do you feel comfortable so far? Good? Happy? Content? Hey, it's Friday. Hey, how was the week that we did twice as much work as we've done all year? 5 days, dude. Hopefully I didn't go real fast and you guys are crying yourselves asleep. I had somebody tell me that yesterday that they cry themselves to sleep because of my class often. Oh, kind of made me feel bad. Math shouldn't make you cry. Of course, I wanted to be sarcastic and say, don't worry. These classes are taught every year. You can repeat it next year. But I thought that might have brought tears in class, and I just wasn't ready. I wasn't ready to have that email from a parent saying you made my kid cry in class, and you're a big jerk of a teacher. And these are all things I know. All right. So my friends, 16 is going to be raised to the 1/4 power. What's the 1/4 power of 16? 2, because 2 times 2 is 4, times 2 is 8, times 2 is 16. So 2 to the 4th. So the 4th root of 16 is 2. And yes, I'd like you to make sure you do that. So I'm going to recognize that this is going to become log 7 of just 2. Is that okay? Okay, so I went ahead and I took care of the exponent. It just happened to work that way. It won't always be that way, but we'll just do that. Oh boy, I have a subtraction sign in front of this being condensed. Okay. Let's see let's deal with this. First, I'm going to highlight just this inside the parentheses. Okay? I know eventually I'm going to have some denominator, but let's just deal with what I've highlighted. Okay? Let's see. 3 to the 4th power, 4 times 4 times 4, I believe is 64. Is that okay so far? Now, again, I'm just dealing with what's in the yellow. The 1/3 power, so I'm going to have a denominator here. What is the 1/3 power of 125? 5. Good, because 5 times 5 times 5. So I'm taking the third root of 125, which is 5. Then I'm going to say, are they going to make this really nice for us and say, hey, let's go 64 divided by 5, and it comes out an even number? Oh, no, it doesn't work. Oh, boy. So this whole thing, because of this subtraction sign, this whole thing is going to become a denominator of a denominator. Okay, now that's 64 over 5. So let's talk about what that looks like. 2 over 64 over 5. That's ugly. Having a triple fraction. Like, I don't even know what you call it. You have a numerator, a denominator, and then you have another denominator. But the middle denominator is really the numerator or the bottom. It's not playing well, right? So let's do this. We have to recognize if we have triple like this, I can go over 1. So 2 over 64 is 1 over 32. Agree? And then I'm going to take this. I'm going to do the reciprocal. I'm going to flip over 5 over 1. I'm going to flip it over and make it 1 over 5. 5 over 1 flips over. So then that's going to give me 1 times 1. Well, I can do that. 5 times 32 is 160. Were you close on that? Oh. Oh, man. Let's see. So that 1 over 160 is the red part of the 64, or the, oh gosh. Okay. Oh, we got this. So this whole thing here, and now I got that in the way of the other problem. That right there is the same thing as 1 over 160. Yikes. This is not comfortable. And I was just working on the quiz that we have. And I'm pretty sure I don't give anything that nasty to you. I'm sure it's much worse. And we got symbols and smiley faces and palm trees. And you're like, what's this math this guy's doing? So I don't know. Just go with it. All right. That's an ugly problem. That is not fun by any means. But if you can break it up and do slowly on it, and you can recognize that, hey, I have this triple fraction thing, well, then you put the very bottom part over 1 and then do a reciprocal of it, then that becomes a little bit more kind. So I think if you take your time on that, that's definitely not one that I would try and squeeze in my head and see if I could write it down in one step. I don't think I would go that way. And I have the hiccups. Okay. Breather, are we good? Oh, hopefully we don't get like worst case scenario beyond that now. Number 5. Number 5. Okay. This 2 out front is going to become an exponent. This becomes 20 over 5. What's 20 over 5? Ooh. Oh. So this is technically this. And last time I checked, he just told me this. Times 20 over 5, that's 4. Hey, what's log base 4 of 4? 1. So do I even have to bring that 2 up as an exponent? Or could I keep it out front? It's up to you. But no matter what, that 2 is going to come down. So log base 2, or 2 times log base 4 of 4, that's going to be 2 times 1, which gives me 2. So this part here gives me an answer of just 2. Okay. So I get 2 plus Does everyone agree why everything went away? Okay. Plus, if I move that 1/3 up with 27, I get 27 raised to the 1/3 power, which is the third root of 27, and I think that comes out to 3. Agree? So plus log base 4 of 3. Now, I know some of you might say, well, wait a minute, is that okay to have? Absolutely. Things could work out nicely, but when you have those rules down, you might be able to talk your way through it. So 2 plus log base 4 of 3, I think we're totally content and good on that one. There's no more pushing it together. Okay? All right, I think I feel okay. Let's go get ice cream. With me? Cole's buying. And when Cole's buying, I'm getting the biggest blizzard. I'm getting the one that you actually have to climb into and rappel down and eat the rest at the bottom. That's kind of like. Of course, when we go to the Dairy Queen with my wife, she's like, are you sure you need that size? I didn't order it if I didn't need it. How about we get you the child size? No. I don't like going to Dairy Queen with my wife. There's like rules that she applies. Go to dinner. Are you sure you want the triple cheeseburger? I'm getting it because we're gluten-free. It's on lettuce, so it's good for me. You sure you need 3 patties? I mean, each patty's a ½ pound. Uh-huh. I'm sorry. I don't know where my mind's going. The cheese has fallen off my cracker for sure. Okay, so how can you write each of the given numbers in terms of 2 and 5 only? Well, 10's the same thing as 2 times 5. Agree? 20 is the same thing as 2 times 2 times 5, which is the same thing as 2 squared times 5. Agree? 50 breaks down to 2 times 5 times 5, because 2 times 25 is 50, which this then breaks down to 2 times 5 to the second. And this is going to make sense in a little bit why we're doing it this way. 2 times 250 is 2 times 125. 125 is the same thing as 5 times 5 times 5. So I could write this as 2 times 5 to the third. And again, this is going to make more sense in a moment on our next slide. Okay? Like, did we just step back to like 5th grade math? Yeah, prime factorization. You remember doing that? You did the factor tree. Some of you did it as this fancy tree, and then you always lost the very last corner, bottom corner, what number you forgot about? Or is that just stirrup? It's probably just me. All right, so notice this one. So this kind of problem, we don't want to necessarily do with a calculator. Yes, on a calculator, I can hit log 18, and it's going to give me something. But I'm going to give you a subtle, small little hint. This test that'll be coming up a week from Monday, you can't use a calculator on it. Well, you can use a for function. You're like, what's that? Okay, so this is where you find the for function. You go into your kitchen. You still with me in this adventure? There's a drawer in your kitchen. That's the catch-all for everything. You open up that drawer. There's a bent, out-of-shape paper clip. There's a stapler that hasn't worked since '77. You know what I'm talking about? There's 5 flashlights that none of them work because the batteries are dead. And then you get a couple of batteries that don't, like you think this might go to the smoke detector, this goes to the remote controls, but these 17 batteries over here don't work, but we're holding on to them because they might work someday. Also in that drawer is this calculator. And you're going to be jealous of me. I got this really, really cool calculator. So sometimes you find this kind of calculator. Okay, watch this. I don't know. Can you all see this? If you can't see, you got to stand up. This is amazing. This is the most amazing thing. Okay, ready? You're going to be so jealous. You're going to wish your cell phones did this. Okay? So I go and to open it, I hit the button, and it comes around. Oh, yeah. Yeah. So this is called a for-function calculator. Yes, you can do. You're all jealous that you don't have that kind of stuff. You want your cell phone. Maybe the iPhone 26 will have that. If not, contact Apple saying, dude, we saw this calculator. It has a lift. It's, it's great. All right. So So my friends, they tell us that log 3 is about 0.48. Okay, we're rounded to decimals. They tell us that log 6 is about 0.8. Again, we are rounding it. We also know that log 4 is about 0.6. Okay, so what we want to do is we want to attribute that to this. So I'm going to break 18 down, and I want 18 to be in terms of 3, 6, or 4. And I think 3 times 6 is 18 this week. Agree? So this means that this is log 3 times 6, which expands to log 3 plus log 6. And if you look up above, you know that log 3 is 0.48. And you know that log 6 is 0.8. And you just add. Oh, I don't know. What do you think? This is when you get stuck. I have to give the right answer, so I'm busting out. I'm sorry, this is not a 4-function calculator, but don't hate me. 0.48 plus 0.8 comes out to 1.28. So this first one is 1.28. Okay, so if we had done that on the calculator, if I did log of 18 on a calculator, if I was allowing that, it would have told me that the answer would have been roughly 1.26. Okay, it's actually 1.255272505. Keeps going, but we came in good. Okay, let's see. Number 7, I want to break 36 down in terms of 3, 6, and 4. Now, a legal thing to do, a totally illegal thing to do, is you recognize 6 squared is the same thing as 36. Agreed? So this is the same thing as log 6 squared, which is 2 log 6. And we know from above that log 6 is equal to 0.8. So I'm going to go 2 times 0.8, and that's going to give me 1.6. See, I can do some arithmetic in my head. How you doing, Cupcake? You all done? Yeah, you just go stick it back in there. Will you let me know if there are 8 calculators in there once you put yours back? If not, somebody ran off with it, which is always possible. Is there 2 empties? Perfect. Appreciate you. Sorry about calling you Cupcake. We'll call you Sunshine or Farm Fresh Egg Boy something. All right. Now, this is one where we start looking going, log 2. Well, I only know log 3, log 6, and log 4. So there's something I could do with 3, 6, or 4 to make it look like a 2. Do what? Divide by 2. So I can go 6 divided by 3. 6 divided by 3 is 2, right? Am I right? Okay. So I'm going to say, well, I can say that this is log 6 over 2. Agree? No. 6 over 3. Is that what you said before? You can, but I want to use the things up there. Log 4? Wait. Did I did 4 is double of 2. You're right. Oh, ew. Okay. I agree with the primary arithmetic, but putting log out front is going to throw a wrench in that game. I'm sorry about that. I loved your idea, though. Do you agree with me that 6 over 3 is 2? And I have log 6 up top and I have log 3 up top. Agree? So that means because the 3 is now a denominator, this is going to be log 6 minus log 3. Agree? And because we're smart and we can visualize the cues, and you have a teacher that has lost his marbles. Log 6 they tell us is about 0.8 minus log 3 they told us is 0.48. I think if I do this right, this is going to come out to 0.32. What do you think? Am I close? Most of you have been with me all year, and you just kind of deal with my discrepancies. Some of you transferred in here, and you're going, I want my old teacher back, and I'm sorry. The rest of you just think that this is how all Algebra 2 teachers are. They're like little, I'm sorry. If you see me like out walking in the middle of the road somewhere, swerve around me. don't swerve into me. Well, maybe if you swerve, that'd probably be better. So just make sure you break my femur. And then listen as the bone breaks, because that's an amazing bone to break. You don't ever want to do it, but if you ever hear it done, it is a loud, oh, yeah, no, it's not good. I'm sorry. What'd you guys do in math class today? I don't know. Stirrup, listen to the video. He's off. He's off his rocker. Yeah, you get that right. All right. All right, my friends. Oh, boy. So we got to remember we're trying to use the 3, the 6, and the 4 to get to 54. But we also know that 54, we can deal with things that are squared. So I think 9 times 6 is 54. And you're like, 9's not up there, genius. You're right. But 9's the same thing as what? 3 squared. Okay? So I know that this is the same as this. Let's do a different color. That doesn't look fun. They clash. Okay, so I know that log 9 times 6 is 54. And I realize 9's not up there, but you're all smart. Thank goodness, because you wouldn't make through this class without that, because you got an illegitimate teacher. So you get that. Agree? Okay. Which means if I expand this, I'm going to get 2 log 3 plus log 6. Does that seem to be okay? Does that work? Okay, log 3, they told us, is 0.48, so I'm going to go 2 times 0.48. I know that log 6 is 0.8. And then 2 times 48 is 0.96 plus 0.8. What do you think? 1.76? I like that answer. I did it without a net. Well, you guys were my net. Thank you. Thanks for catching me. All right. Is this okay? Am I done with slides, or is there so many more? It's like, really? No matter what, we're done. We're done. We are just done. No, am I done? You serious? Wait, what did I just do? No, we got much more. You're talking like my freshman now. Is there any questions? No, there are no questions. Can we go? Yeah, but you got a 1% in my class. You sure you want to go? Don't you want to try and get to a 2%? Oh. Okay, breather, we're good. Who wants to work the next problem out? Someone want to come to the board, have the microphone? It'd be cool. Do you really? You're buying his ice cream and you're going to teach? Oh, man, this is the best day ever. Oh, man. All right. Hey, this is another one just like we've just done, but they tell us, hey, log 3 is about 0.5, log 6 is about 0.8, and log 4 is about 0.6. Okay. So I know that this is going to be log 81 minus log 4. Agree? Now, 81, oh, shoot. 81 is 3 times 3 times 3 times 3, 3 to the 4th. So this is the same thing as 4 log 3 minus log 4, which is 0.6. Everyone follow my madness? Okay. Log 3 is 0.5. 0.5 times 4 is 2. 2 minus 0.6 is like 1.4, I believe. As usual, when a hand goes up. Nope. Buddy. Your arithmetic's wrong. Oh, boy. They got mean. 0.0006. That's like 6 over 10, 100,000, 10, 100,000, 10,000. Oh, boy. I know that log, this is going to be log 6 minus log of 10,000. 10,000 is 10 to the 4th power. So what would log base 10 of 10 to the 4th, what would that just simplify to? Nope, no log 10. Just 4. Okay, it's 4. And log 6, they told us up top is 0.8. So I get 0.8 minus. So this is going to give me negative 3.2. Yes, there is a decimal at the bottom of the 3, and there's one between the 3 and the 2 as well, just because it seemed like it was a good idea to do that way. Whew. Man, these got a little extra horsepower. Like, I have to use my imagination to do some of these. Okay. I got a negative 3 up front. I don't know if I'm going to mess with that negative 3 right away. Just for fun, let's switch to orange. All right, so I got negative 3 times log of 72. 72 is what times what? 6 to the 12th is 72? 6 and 12. 6 and 12. 6 and 12? Really? So this is log 6 times 12, and 12 is 3 times 4. And we had all that up there, right? Oh, you're so smart. I'm glad you're here. These are all being multiplied. That means we're going to add them when we expand it. And then we have negative 3 times log 6. They told us is 0.8 plus log 3 is 0.5 plus log 4 is 0.6. Okay. 4 function calculator time. Yes, more than 4 function. Just because I don't feel like trying to add decimals together and having you all laugh at me like you always do. So I get 0.8 plus 0.5 plus 0.6 close parentheses. So that comes out to negative 5.7. All right. Can any of you name for me at least 2 famous people I've taught? One guy, okay. Yes? Matthew Gray Gubler from Criminal Minds. Yeah, Dr. Spencer Reed. He was a former student of mine. Yeah. Anyone know the second person? Second famous one? Well, yeah, that was Michael Leon, but he doesn't tap dance anymore. Anyone else? His name's Schaefer Smith. Who's Schaefer Smith? Okay, a couple of you got a phone out. Ask Siri, who is Schaefer Smith? S-H-A-F-F-E-R, maybe? Neo, there you go. Yeah. Only a couple famous kids. I have another student of mine who, her and her family are actually on a Netflix series now. Have you seen the show? I think it's called Countryish on Netflix. It's got Chrisella Anderson. When I had Chrisella, it was Chrisella Crossland. And her husband, I don't know her husband. I'd never met her husband. Her husband is a country western singer. His name's Cafe Anderson. So they got a Netflix series on right now. Chrisella was an incredible dancer. Still is. She has danced with Britney Spears and Snoop Dogg and a whole bunch of other big acts out there that she has been, dancing on stage while they're doing it. She is now. They moved to Dallas. They were living in Los Angeles. They moved to Dallas, and she is now the choreographer for the Dallas Cowboys cheerleaders. So that's, it seems like cool. So again, because you all had me, y'all gonna be famous. That's the connection they have. They had me. They're famous. You had me. You'll be famous. That's great. All right. Last one for this page. I'm gonna say this. Do you agree? 1/3 comes down front. Log 6 is 0.8. Oh my gosh. So this is going to be about 0.3 times it's going to give me 0.24 roughly. Because 0.3 or 1/3 is 0.3 repeated forever. 0.3 times 0.8. hiccup time is 0.24. Okay, 2 slides left, 5 minutes left. Okay, I could do it. I'm pretty sure you might feel comfortable with these. Are these done the same way? So this would just break up to log base x of 4 plus log base x of 7. You have them up above. Log base x of 4 is equal to b. Log base 4 of 7 is equal to c, so b plus c is that answer. The 1.75, I would convert 1.75 into 1 and 75 over 100. 1 and 75 over 100 is going to convert easier. But these should be doable. I would convert this one. I would not give you something like this on a test, though. This one, log base x of 4 squared. 2 comes down front. Log base x of 4 is equal to b, so this becomes 2b. Yes, I put it in parentheses. And then do the same thing with the 49. 49 is 7 squared. The 2 comes down front. Break up the 12. So I think this is going to give you 2c minus a minus b. I think that's what it's going to do. Now let's leave that. If you want to go over that more, we can. Last slide. Done the same way. Last slide is going to be done the same way. Okay, bring the 4 down front. Log base x of c. Log base x of c is equal to 4. So this becomes 4 times 4, which is 16. Log base a and c. This is going to be add. So log base a, that's going to give me 3 plus log base a of c. 3 plus 4 is 7. And I think I've done enough for the week. Hey, do you guys want a whole bunch of homework tonight? How about tomorrow night? How about Sunday night? How about before school starts on Monday morning when you're like, oh, I had the whole weekend and I did nothing? All right, so worksheet 9i, evens or odds? Odds, sounds good. How about we do this? Odds or evens, that way no one feels left out. Sound good? Or 20 honest minutes. Deal? Hope I taught well. I think I did. You guys just laugh at me. It's like being at home. What Dad do now? Just let him be. Say